Hello, my name is Ryan Beam, and I'm a student at the University of Kentucky studying economics and data science. In this series, I explore how data and AI are applied in real-world settings and how the field is continuing to evolve. Today, I'm joined by Kurt Smith, a member of the technical staff at Essential AI, with prior roles spanning DoorDash, StitchFix, Twitter, and Microsoft AI. Kurt, thank you so much for being here with me.
Thanks for having me, Ryan.
Yeah, so just to kind of get us started and jumping into a little bit about your career path, I know you have a PhD in chemical engineering, but you've built a career in data science and now AI. How did this initial pivot happen, and what's motivated some of the bigger transitions since that?
Yeah, that's a good question. So it's a kind of a funny story. I would say I would even go back before that pivot to when I first when I first went to college. So I grew up in a somewhat small town in New Hampshire, and I was always really interested in math, physics, kind of things in that vein. And as I was thinking about what to major in college, the natural choice probably would have been math. I think at the time I was very focused on career paths and having practical skills and coming from a smaller town. I somehow in my head I always thought I never met anybody who was a professional mathematician, and I had this very narrow sense of what you could do with a math degree. And so I a lot of friends at the time who were similarly kind of STEM focused really heavily recommended engineering. And so I ended up choosing engineering as a major, choosing chemical engineering because it sort of had the most sort of physics and science foundation to it of all the engineering fields. I felt kind of went down that path, was interested in studying and researching more after college, and went into grad school, did a PhD in computational fluid dynamics. Really, enjoyed that time, learned a lot of interesting stuff. And then I sort of, after my time in academia, ended up for kind of personal reasons moving out to the Bay Area, and really just kind of through good fortune happened to be here in the time when tech really started taking off. And so, I had been looking at various jobs in more traditional chemical engineering industries. And then at one point came across an opportunity to join a startup here that was doing sort of healthcare analytics and mathematical modeling, and was hiring folks with any sort of mathematical modeling background, physics, in other economics and other fields. And so that was really my kind of first transition into a more, what I'd call sort of a data science role. And this was right in the days when data science was becoming this sort of new career field. So spent some time there, and then after several years there, tech really started to take off, particularly here in the Bay Area. And I decided to make the leap fully, and from there move to Twitter. That was sort of what I would call my first full-fledged tech role. And so that was sort of my transition. I think it happened a bit earlier than it might have because I just happened to be in the Bay Area right when all this happened. But I think even if I had not, probably at some point down the line, I would have kind of made the shift maybe a few years later.
Yeah, that's really interesting. What kind of work were you doing when you transitioned to Twitter for that starting role?
Yeah, so initially, my very first kind of data job, we were building a lot of models to predict health risk, right? So thinking about things like cardiovascular disease, diabetes, cancer, a lot of the common disease categories that a lot of medical care, medical spending goes towards. It was a really interesting, and so then, we were using this to a lot of our clients were healthcare providers or insurers. So we were using this at kind of like a broader public health to craft effective strategies for public health. What was interesting to me, my math background up until then had all been basically rooted in partial differential equations, right? A lot of applied math for physics is based on solving various PDEs. And so moving away from, this approach where you have some governing equations that describe some system to a really like data first approach where we'd start with some data from a longitudinal study or a clinical trial, and then build a statistical model that was not at all based on some first principles model. It was such a shift in the way of thinking and approaching a problem for me. I remember it really took me some time to get out of the old kind of governing equation based mindset to this different way of using math to solve problems. And so that was, I learned a lot of statistics. I learned a lot of R in particular for data analysis and data visualization. A lot of skills that then, after a few years there, served me really well in moving into, sort of tech proper, that is, in going to Twitter.
Yeah, that's really interesting. If you don't mind me asking, I know later you worked for StitchFix, and one of my side projects is I have a small like clothing e-commerce business that I'm really trying to build out, and it's been a way that I can practice some of these data-related processes and apply it to a real business and see, the effects on money and see my bank account go up and down based on decisions I make. So it's a really enjoyable thing that I'm getting there, and so I was curious what you did at Stitch Fix on what I'm doing, except on a much different and huge scale. Because I was interested to see, especially what the transition you took there and what kind of projects you're working on there.
Yeah, absolutely. So Stitch Fix was an interesting company. It had, particularly at the time that I joined, a relatively large and strong algorithms organization. Particularly relative to the overall size of the business, they put a very heavy investment in algorithms for everything from the product, the consumer side, to operations, to managing warehouses efficiently, et cetera. So I specifically led a recommendations team that focused on providing recommendations for the items we would choose to send to our customers, or giving recommendations to our stylists who would make the final decisions. I think one of the things, as I'm sure you're aware, there's a lot of areas where recommendations plays a key part in helping people find things. That could be in social media, in lots of other categories, in commerce, et cetera. Personal fashion and apparel in particular is an area where there is a very diverse range of personal preferences and tastes, but also types of fashion and clothing. So I learned quite a lot about that. It's a rich area for recommendations. It's also an area where it's, compared to like healthcare I mentioned before, right? It's somewhat lower risk. So there's the downside to sending someone an item they don't like is much lower, and so you can afford to explore a lot more, right? To balance that exploration exploitation trade-off that you may have heard of that comes up a lot. So that's what we focused on. One of the key things I would say there, one of my colleagues in particular had this great insight that the key bottleneck for us to making great recommendations to our customers was getting enough data on their preferences. Unlike Facebook or Twitter where people are constantly clicking, people buy new clothes at only a certain frequency. And so we actually developed this product called Style Shuffle, where people sometimes called it a Tinder for clothes, where we would show you a bunch of items and you would thumbs up or down if you liked each one. And our customers really loved playing with that, and it gave us a lot of rich data on people's preferences that let us improve our recommendations. So it was an interesting learning that it's not just sort of the algorithms and the statistical analysis that matters. Sometimes it's actually like unlocking ways to collect data that feed into that can be the key factor.
Yeah, I think that's a very interesting way to collect that data to kind of gamify it in a way. I think that's
Exactly.
the thing I don't think a lot about getting the data because especially in school, with pursuing statistics and data science, a lot of the data sets I get are clean. They've been taken from different sources. That's something I haven't worried and had as much experience with. So that's a really interesting insight. So kind of moving on, at companies like Stitch Fix and DoorDash, experimentation like that directly impacts revenue and user experience. And so, especially coming from a background with a PhD where you were conducting research, how do you think about experimentation and iteration when the cost of being wrong at these companies is so high?
Sure. That's a great question. So what one thing I would say to kind of frame that um, so the cost of being wrong can be high, certainly in that like if you roll out a really bad user experience, you can burn trust with users. You can also more concretely lose a lot of money in the near term. The flip side, I would say, when you're in any sort of fast-paced consumer-facing industry, that can be apparel, that can be social media, et cetera. The flip side of that is the cost of not experimenting, right? The cost of sort of being static, of maintaining the status quo is also quite high, right?
Mhm.
Like in all these areas, products are always evolving, new competitors are coming out doing new things, and so in a sense, there's actually strong pressure to be experimenting and constantly evolving. Otherwise, your business will likely not survive at the state that it's at. So it's important to weigh that trade-off. Um, as far as experimentation, the way we think about it, I would say the one key thing in any space, any sort of consumer-oriented business where you're doing a lot of experimentation, I think that the key thing at the root of all of that is understanding what your North Star metrics are. What are the things you should be optimizing for that will, promote the long-term health and growth of the business and customer satisfaction. And what I mean by that, it's very easy to optimize for revenue. That can be sales, that can be ad clicks. That's something that's very easily to measure. The feedback loop is very short-term and very tight. But you can absolutely burn trusts of your customers or your users in the long term. So thinking about like what are the right measures, often you'll have maybe a suite of different things of different metrics that you're trying to improve. Revenue will be one, retention may be another, et cetera. But really being thoughtful about that, and then doing experiments that that move all of those in the concert, so you don't just over-index on short-term metrics.
Right. Thank you for that. That's a really interesting insight there. So I appreciate that answer. Kind of moving off that, you've moved between hands-on roles and technical roles and leadership positions. And how did your perspective change when you shift back and forth from building models yourself to managing other engineers and data scientists?
Yeah, that's a good question. And I think it's one of the unique things, in our industry for folks working in tech and technical roles, as opposed to other career paths. I think there's a lot of fluidity in moving between individual contributor roles, as they're called, and management roles or leadership roles, and then moving back. A lot of folks do move back and forth between those, as I have myself. And so part of that has to do with, I think, a couple of reasons. One, things in technology or software, broadly speaking, things evolve and change really rapidly, right? We've obviously seen this with AI in the last few years. So it's a field that is very dynamic, not at all static. And so even as a leader, often every few years, you may find yourself wanting to go back and spend some time getting that hands-on experience to be able to, uh, uh, um, think in more depth about the state of the field and what you can be doing with technology as the state it's currently at. So that's one part of it. But to the other part, actually, moving, and I remember the first time I moved into a leadership role was at Twitter. I think moving from from an IC or individual role to a leadership role, some of the things that I found important, um, I would say two things. One, being able to communicate clearly and across that. There's sometimes a gap between the technical folks and the other folks in the business, product, business strategy, other areas of the business. So being able to communicate clearly and succinctly, both the technical work and the technical decisions that need to be made to other folks and the trade-offs that you face, as well as being able to communicate to the folks on your team, the more technical folks, sort of the broader business strategy and why we're making certain decisions over other decisions, and recognizing that there are, in any business, there are always going to be decisions that need to be made and paths that we choose not to take, and not everybody may agree on every single one of those decisions, but that is just the nature of working in a business. So that communication skill, I think, is one big part of technical leadership, and it's one that I particularly enjoyed. The other thing I would highlight is prioritization. Being able to understand, there are a finite number of things we'll be able to do and do well, and recognize that some things are going to be below the line of what we choose to take on in any given quarter or year or what have you. And so being honest and upfront about that, and having an open discussion about thinking about how do we come to a framework for prioritizing all the various things we could do, and then make decisions about both how to rank things and how many of those things at the top of our list to take on at any given point in time.
Right, that's really interesting, and especially what you were talking about with bridging that technical gap between kind of the business leaders and the more technical roles. And that's something as I go through school, where I'm double majoring in a more technical role with statistics and data science, and a less technical role with economics, kind of that business side of things. That's something I'm really trying to navigate and hoping to help prepare for my career as well. So thank you for that. Now I just kind of want to move on to kind of the AI side of things, especially right now. So you work at Essential AI. I know you've been really busy recently because they released a new model. So at a high level, what problem was this model designed to solve, and how does it reflect the way your team thinks about building practical AI systems?
Yeah, you can read a lot more on our website, essential.ai, about about this model, Range 1, which we released in December. This is an 8 billion parameter open weights model specifically focused on math and STEM capabilities and reasoning in those domains. So we made a decision about a year ago to really focus in this direction, building strong open weights models. We made a particular bet that we talk more about in our blog post. We felt there was a lot of room to produce improvements in the pre-training stage of model development. So if you're familiar with AI or LLMs, pre-training is sort of that first stage where you train models on very large amounts of data that is then often followed by a post-training stage, which includes fine-tuning and reinforcement learning. So we made a particular bet that we thought there was a lot of opportunity to show improvements in the pre-training stage, and particularly, as I said, for math and code. And so that's where we really put a lot of our efforts over the past year. And if you see from some of the published benchmark results that we shared in the blog post, we're really pleased with some of the results that we got.
Yeah, that's really interesting, and I'm excited to read more after this interview concludes because that sounds super cool. Kind of just moving on to the more personal side of AI, and kind of in your life, you know that AI is advancing at an incredibly rapid pace, as you said earlier. How do you personally decide which ideas, tools, or directions are worth investigating in versus ignoring some of the hype?
Yeah, I will say that is a tougher and tougher question over the past few years because there's just so much happening in the space now. Just keeping up with the research literature is, in itself a full-time job. So I'll say, a bit about my personal career path. As I mentioned, I was at, or as you may have mentioned earlier, I was at DoorDash for close to 4 years, where I led a machine learning team, built out that machine learning team, and was there at the time that ChatGPT came out a few years back and really, kind of opened the floodgates for people seeing the potential of AI. So that time, like I alluded to earlier, that was really the point that made me think seriously about moving back to a hands-on technical role and just getting a lot more direct experience working with and building AI models. So that's what I've been doing for the last couple of years at first Inflection and Microsoft, and then for this past year at Essential. A couple a couple skills I've tried to develop over the years. I think we're fortunate in this space that um, a lot of these developments are published in literature, or the various open source models that folks can try out. And so I think one important bit of judgment is getting good at reading through papers, thinking about what ideas that are coming out are not just interesting but also directly applicable, things where you can try out and get some feedback. Um, get some feedback if they're working for your particular problem that you're working on. Um, so that's I think that's a skill that I'm always developing and cultivating. Um, I would say, in addition to that, I think, I talked about earlier, having a clear sense of sort of your North Star metrics or goals, and I think the same applies here, right? Setting some objective, whether that's a business objective and we have some product that we want to succeed, or whether it's a broader, there are companies that are more focused on let's say technical challenges than product challenges. We want to be able to solve this category of problems or build models that have this capabilities. But having a very clear sense of what your goals are, having some metrics that may not be the perfect metrics, but some metrics that you can measure and give you some feedback, and then really using those to decide when to place your bets and how to measure if those bets are succeeding.
Yeah, thank you for that. I think I really can gain a lot from that when I go back and reflect from what you said, because especially that whole North Star thing you've reiterated over and over, I think that's really powerful. So kind of moving off kind of that advice you've given already, the insights I'm already taking from our conversation. If you were in my shoes, 19 years old, studying economics and statistics, interested in data, AI, and even machine learning, what advice would you give about exploring and building a durable career in the space that's kind of ever changing?
Yeah, well, that I think that is probably the toughest question of any you've asked me. It is such a rapidly evolving space. Like we said, I started out in chemical engineering. Interesting thing, my father was actually a software engineer for his career. Going back to the 70s and 80s, and software was a whole different thing in those times. And so, talking to him about those days versus where we are with AI now, it's this whole space is constantly evolving. There's no one set of technical skills, of being licensed or certified for these specific technologies that's going to last you for your career. Even what we're seeing with AI right now is the nature of writing code, the nature of programming is evolving as we speak, and a lot of software engineers are rethinking what their job entails. So I think some concrete things I would say is one, just expect lots of change over the course of your career. Expect that there will be new technologies, methodologies that you will constantly be learning, and just stay open to that. Really think about your adaptability and your ability to learn new skills over time, because you're going to be, in the coming years, you're going to be learning even more and more new things going forward. So I think that is really important. Another thing I would say, so you talked a bit about statistics and economics, and so you like myself, you're coming to this not from a sort of computer science or software engineering background, but from other quantitative fields. And I think there are a lot of valuable things that folks bring from those other fields. So economics in particular, one thing you see a lot of in that space is causal inference and causal analysis. There's a lot of methodology has been developed by economists to solve those kind of problems, and those are similar and related, but different from a lot of the sort of prediction problems that most standard machine learning is developed for. And so having frameworks to understand things like that, sort of the similarities and differences between prediction and causal inference problems. Statistics, again, is another great field that has a particular paradigm or a way of thinking about the types of questions statistics has been developed to answer, which again are similar but somewhat different from what a lot of folks in machine learning think about. And so there are pros and cons to each, but having appreciation for, so maybe I would say there's kind of three distinct paradigms: machine learning, statistics, and economics or causal inference. Understanding the key insights from each of those and how to merge them and when to sort of lean on one or the other of them for the particular problem that you're trying to solve. I think that's, aside from the direct technical skills, that kind of broader perspective is something I find is more and more valuable the further I go in my career.
Well, thank you so much. I really appreciate that advice. And thank you again for taking the time out of your day to meet with me.
Thanks. It was great chatting with you, Ryan, and wish you the best of luck in your career.
Thank you. Likewise.